The sun, a blazing ball of fire at the heart of our solar system. It's a giant fusion reactor, producing the energy that sustains life on Earth. But the sun is more than just a source of light and warmth. It's a complex and dynamic star filled with mysteries and unimaginable power. Let's start with the basics. The sun is a nearly perfect sphere of hot plasma, made up mostly of hydrogen and helium. It's roughly 1.4 million kilometers wide. That's about 109 times the diameter of Earth. Its surface temperature? A scorching 5,500 degrees Celsius. And at its core, temperatures soar to a mind-blowing 15 million degrees Celsius. The sun formed about 4.6 billion years ago from a collapsing cloud of gas and dust. Since then, it's been shining non-stop, converting hydrogen into helium through nuclear fusion. This process releases immense energy that radiates outward, giving us light, heat, and life itself. Sunspots, which are cooler regions on the sun's surface, appear and disappear over time. The sun also emits a stream of charged particles known as the solar wind, which affects the entire solar system. When these particles interact with Earth's magnetic field, they create stunning auroras, also known as the northern and southern lights. The sun's magnetic field is incredibly complex and influences solar activity, including solar flares and coronal mass ejections. The sun goes through an approximately 11-year solar cycle, during which its activity levels fluctuate. In the distant future, the sun will evolve into a red giant before shedding its outer layers and leaving behind a white dwarf. For now, we can continue to marvel at the sun, our life-giving star, and its many wonders. The sun has several layers, each with its own role in generating and transferring energy. Understanding these layers helps us comprehend how the sun functions and affects our solar system. The core. This is where nuclear fusion occurs, creating energy that slowly moves outward. The core is incredibly hot and dense, with temperatures reaching around 15 million degrees Celsius. Here, hydrogen atoms fuse to form helium, releasing vast amounts of energy in the process. The radiative zone. Energy travels through this region for thousands of years before reaching the next layer. In this zone, energy is transferred by radiation, and it can take millions of years for a photon to travel through it, due to the dense material. The convective zone. Here, hot plasma rises and falls like boiling water, bringing energy to the sun's surface. This movement of plasma creates convection currents, which are responsible for the sun's magnetic field and surface activity. The photosphere. This is what we see as the surface of the sun, a bubbling sea of hot plasma. The photosphere is about 500 kilometers thick and has temperatures around 5,500 degrees Celsius. Sunspots, which are cooler, darker areas, can also be observed here. The corona, the sun's outer atmosphere, it's millions of degrees hotter than the surface, and during solar eclipses, it appears as a stunning halo around the sun. The corona extends millions of kilometers into space and is the source of the solar wind, which affects space weather and can impact Earth's magnetosphere. The solar wind streams of charged particles released from the corona. These particles travel through the solar system and interact with planetary magnetic fields, creating phenomena such as auroras on Earth. The solar wind also shapes the heliosphere, the bubble-like region of space dominated by the sun. But the sun isn't always calm. Sometimes it erupts with powerful bursts of energy called solar flares. These flares release massive amounts of radiation and can trigger solar storms, disturbances in Earth's magnetic field. At its most intense, solar activity can disrupt satellites, communication systems, and even power grids on Earth. These outbursts are part of the sun's 11-year solar cycle, which peaks during periods of maximum activity. Scientists carefully monitor the sun to predict and prepare for these solar storms. Historical records show that significant solar storms have caused spectacular auroras and even disrupted telegraph systems in the past. Today, with our reliance on modern technology, the stakes are even higher. Satellites, GPS, and power grids are all vulnerable to these solar events. Using advanced tools and computer models, scientists strive to predict solar flares and storms with greater accuracy. International collaboration is key, as space weather monitoring becomes a global effort to safeguard our technological infrastructure. Public awareness campaigns and educational outreach are also crucial in preparing society for potential solar storm impacts. Future missions aim to study the sun more closely, providing invaluable data to help us understand and mitigate the effects of solar activity. Without the sun, life as we know it wouldn't exist. Its energy drives Earth's climate, powers photosynthesis, and fuels the water cycle. The sun's energy is the cornerstone of life on Earth. It provides the warmth and light necessary for plants to grow, which in turn supports the entire food chain. Through photosynthesis, plants convert sunlight into energy, producing oxygen as a byproduct. This oxygen is essential for the survival of most living organisms. The sun also drives the water cycle, causing water to evaporate from oceans, form clouds, and eventually fall as precipitation, replenishing freshwater sources. But the sun also has a darker side. Its intense radiation is harmful in large doses. Solar flares and coronal mass ejections can disrupt communications and power grids on Earth. And one day, billions of years from now, it will become a red giant, expanding and swallowing Mercury, Venus, and possibly Earth. In the far future, the sun will shed its outer layers and become a white dwarf, a fading remnant of its former self. But until then, it remains the central force in our solar system, shaping everything from planetary orbits to weather patterns. The sun's influence extends beyond Earth, affecting the entire solar system. Its gravitational pull keeps the planets in orbit, and its solar wind shapes the heliosphere, a protective bubble that shields the solar system from interstellar radiation. The interaction between the solar wind and Earth's magnetosphere creates stunning phenomena, like the northern and southern lights, reminding us of the sun's powerful presence. As we go about our daily lives, it's easy to take the sun for granted, yet it remains a constant, life-giving force central to our existence and the natural rhythms of our world. The sun, a life-giver, a destroyer, and an endless source of wonder. As we continue to explore the cosmos, our understanding of the sun will grow, helping us unlock even more of the universe's secrets. Thank you for watching. If you enjoyed this journey into the heart of our solar system, be sure to like, subscribe, and join us for more space discoveries.